Good afternoon, I'm Mr. Rich. Thank you for joining me. We're looking here at a very interesting question: how much heat is stored in ice and in steam? We're looking here at a quantity of 1 mole of water, which is 18 grams. Again, how much heat can you find stored in ice and how much heat is stored in steam? If you think about the heat of fusion of water, delta H fusion, it has two reactions. If you're going from water, from the solid phase to water into the liquid phase, you're melting ice. There's a certain amount of heat of fusion, and that is positive. It's an endothermic reaction, it's positive. 6.02 kilojoules per mole. But if you're looking at water being frozen from liquid form into solid form, it's an exothermic reaction, because when water freezes, it releases heat. Here would be 6.02 kilojoules per mole, an exothermic reaction. Either of these reactions gives you a quantity in terms of how much heat is stored, and it's this. All of these are with regards to per mole. If you want to know how much heat is stored in ice, you're getting a value of 6.02 kilojoules per mole. The positive and minus only indicates the direction, if it's endothermic or exothermic. If you look at delta H of vaporization of water, here you can look at it either of two ways. You're going from liquid water into steam, and we'll put gas. And then here, when you evaporate water, it's a positive. It's 40.7 kilojoules because it's a endothermic reaction. When you go here in the other direction, when you condense steam, you're going from gas now to liquid, the value changes here in terms of sign only. It's minus 40.7 kilojoules per mole, because in each of these instances the sign is only thing that differs. The quantity of heat stored is the same. This here is an exothermic, this here is an endothermic reaction. Technically, you've answered the question: how much heat is stored in ice, 18 grams of ice, or in 18 grams or 1 mole of steam. It's this. With regards to ice, it's 6.02 kilojoules per mole. With regards to steam, it's 40.7. But how can we give this question a little bit of meaning in terms of practical application? Because just me telling you there's 6.02 kilojoules of heat stored in ice or 40.7 kilojoules of heat stored in steam does not mean much unless I compare it to something useful. And what is that? How about we talk about heat capacity of water? If I have 1 kilogram of water, which is 1000 grams, how much can this ice heat, or how much can this steam heat raise the temperature of that amount of water? It would give you an indication of how much heat is then stored in either ice and in steam. If we're looking at ice, we have 6020. Everything here now has to be converted into joules for your heat capacity calculations, and into grams. You have 1000 grams of water, you have a heat capacity or specific heat capacity of 4.184 in delta T. What is delta T, or change in temperature? How much can you change the temperature or raise the temperature of water, liquid water, using all the amount of heat stored in 1 mole of ice? You just do this. 6020 divided by 1000 divided by 4.184, you'll get 1.4388. You can change it by 1.44 degrees Celsius. Now, with the amount of heat that's stored in steam, it will give you a very good idea of how the two compare. You can use either of those values, but just keep it positive. 40,700 joules is equal to 1000 grams, 4.184 delta T. And here delta T will give you an idea of how much heat is stored in a mole of steam. You'll do 40,700 divided by 1000 grams of that water, which is a kilogram, divided by 4.184. Here you can raise the temperature by 9.73 degrees Celsius, which is a considerable amount. Think about it. In either way, it's a bit of an impressive result, especially with this. But look at everything here with regards to a meaningful comparison. We have 1000 grams over here. If you look at 1 mole of ice, it has enough heat to raise the temperature of 1000 grams of water by 1.44 degrees Celsius. Likewise, when you're looking at a mole of steam, it has enough heat. 1 mole of that steam has enough heat to raise 1000 grams of water by 9.73. It raises temperature by that much. So it's a considerable amount of heat which is stored in steam, and not so much in ice. But either way, with regards to a mole, it's still a good, impressive result. So that's how you would make this question a little bit more meaningful, by this type of a realistic or practical comparison. Thank you for watching this video. Have a good day.